A gas turbine is a dynamic internal combustion engine. For a gas turbine, the vapor condition depends on the type of fuel used and the atmospheric conditions. This is because the inlet to the gas turbine engine is from the atmosphere, and any change in temperature, humidity or pressure will affect the mass flow into, and consequently the power produced by the gas turbine. If we compare the performance of a gas turbine to that of a gasoline engine, we can find that gasoline engine performance more efficient, since both the vapor and the vapor conditions are fixed. Modern gasoline engines have a maximum thermal efficiency of about 25% to 50% when used to power a car. In other words, even when the engine is operating at its point of maximum thermal efficiency, of the total heat energy released by the gasoline consumed, about 50 to 75% is rejected as heat without being turned into useful work. Approximately half of this rejected heat is carried away by the exhaust gases, and half passes through the cylinder walls or cylinder head into the engine cooling system and is passed to the atmosphere via the cooling system radiator. The gas turbine is most efficient at maximum power output in the same way reciprocating engines are most efficient at maximum load. The difference is that at lower rotational speed the pressure of the compressed air drops and thus thermal and fuel efficiency drop dramatically.
Power-to-weight ratio, specific power or power-to-mass ratio, is a calculation commonly applied to engines and mobile power sources to enable the comparison of one unit or design to another. Power-to-weight ratio is a measurement of actual performance of any engine or power source. As helicopters get bigger, their prows can generate more power, but unless the power-to-weight ratio improves, the helicopter's performance, ability to maneuver and climb, will remain the same. In aircraft, power is at even more of a premium than in auto racing, and diesel offer a good performance at high altitude. A helicopter typically requires about 200 watt per kg. Power-to-weight ratio is quite good and efficient and have been used in racing. As for the human-powered automobiles like cycles, rickshaw have low power-to-weight ratio, and for motorized automobile, power-to-weight ratio, and for heavy automobiles, it have poor power-to-weight ratio. Power-to-weight ratio is important factors as it relates to operating efficiency of automobiles.
There are two scales for helicopters: small-scale aeroderivatives and large-scale aeroderivatives. Helicopter can be considered by small-scale aeroderivative engines, also known as turboshafts. Shaft is connected to the rotor blade transmission. Small-scale aeroderivatives are to emanate from the conversion of aero engines of small-capacity aircraft. Turboshaft engines can be divided into two. There are single-spool and multi-spool. The single-spool configurations are basically to minimize weight and suitable for lightweight helicopters. For helicopter, basically the space are required for compressor, turbine, power shaft, air intake, combustion chamber and exhaust nozzle. The concept where a unique compact turbine engine design would provide power for a rear-wheel drive car. Basically, in automotive, gas turbine have compressors, combustors, turbines, exhaust and power shaft. The basic requirements for the turbines are lightweight, high efficiency, ability to operate at high temperatures for long periods, reliability, and serviceability. The selection of blade material depends on the stress, rupture and creep characteristics of the various blade materials, in combination with mechanical and thermal stresses, resistance to mechanical and thermal shock, and resistance to corrosion and vibration. Gasoline or kerosene, helicopters don't need to be brought to the airport for fuel. Comparing the fuel availability, kerosene used as jet fuel is much more refined than the one bought at fuel pump or as home heating fuel. Thus, it is more expensive but cheaper than gasoline. Gasoline in either way tends to burn too fast than kerosene does, which means it could not tolerated by larger aviation turbines, but it is still used in some light aircraft operation. To make it clear, both kerosene and gasoline are easy to find but may vary in demands.
Environmental impacts, such as the noise, air quality, and climate change of aircrafts and other forms of aviation are important for both operations. The exhaust emissions of an aircraft engine can be listed as CO, CO2, H2O, HC, NOx, sulfur oxides, particulate matter, PM, volatile organic compounds, and other trace compounds. Many parameters, such as the air quality, health of humans and environment, are affected by most of these compounds directly or indirectly. On the other hand, car pollutants cause immediate and long-term effects on the environment. Car pollution is one of the major causes of global warming. Cars and trucks emit carbon dioxide and other greenhouse gases, which contribute 1/5 of the United States' total global warming pollution. Greenhouse gases trap heat in the atmosphere, which causes worldwide temperatures to rise. Without greenhouse gases, the Earth would be covered in ice, but burning excessive amounts of fossil fuels, such as gasoline and diesel. The effects of car pollution are widespread, affecting air, soil and water quality. Nitrous oxide contributes to the depletion of the ozone layer, which shields the Earth from harmful ultraviolet radiation from the sun. Sulfur dioxide and nitrogen dioxide mix with rainwater to create acid rain, which damages crops, forests and other vegetation and buildings.